Welcome to Network 8, the 8th lesson in this series. We're still working with networks, protocols and layers, although protocols and layers are going to come shortly. Today's lesson we're going to look at encryption, and part and parcel of what we're going to be doing today, if we take a look down this list of what we've got to learn, I'm going to start introducing standards in this lesson, and some idea of protocols, although we're not going to go into detail with it. We're just going to sort of hear the words mentioned, and particularly if you watch the videos that I present you at the end of the lesson. So it's the lesson's on encryption, but there are sort of peek previews of what is to come. So encryption is basically a way of coding information so it can't be read. Cryptography is the sort of science that belongs to it. It's been used throughout history, from medieval times with kings and queens sending coded messages to one another, and through the war with the Enigma machines and breaking the German codes. It's a rather large topic, and it's very, very useful with computers, because as we use Wi-Fi, we're leaving ourselves open to somebody else being able to read our information, and the information that we send, although you might think it's not important, somebody will find a use for it. And in particular, if you're transmitting bank numbers over the internet, or credit card numbers, or anything to do with finance, you really need to have that sort of safe. So encryption is a way of doing it, and it's an algorithm, it's a method. There's a sequence of steps to actually code the information that you've got. Now the point is that when you send information, you encrypt it on your side, so you code it on your side, and you have a key. And a key is quite an important topic in encryption, which is why we have a picture of a key on the screen. And at the other end, because they know the key and they get the message, they can decrypt that message and get back what was originally sent. Now, normally the message before it's encrypted is called plain text. And then we encrypt it, and the purpose of decrypting with a key is to get back to the plain text. So between the two devices, the encrypted data should not be able to be read. And I mentioned should not with a large pinch of salt, so we have to be very, very careful. So we're going to take a look at it in this lesson. So this is a common term, man-in-the-middle attacks. What happens is when you're on a Wi-Fi network, you'll be sending information from your phone to a wireless access point or to a server, and there can be a person with a device sitting between you and your server or your access point who can try as much as he likes intercept the message that you are sending and decrypt it. For us it's not too much of a problem, but if you think for national security, this is a major area. I'll talk a little bit about that in a minute. So the idea of encryption is to scramble data to make it unreadable. So we're adding a level of security in transmitting the data. We've also got security in the fact that we have to use a username and password to log on, but this adds a level of security, and in particular to a wireless network. There is also the possibility of a wired network being hacked and attacked, but it's not so common as a wireless network. I mean, you've got to think that if you're out in town using the cafe's wireless access point and you're doing a little bit of shopping, you really are leaving yourself open to attacks. Anybody in that cafeteria, and as you'll probably see a little bit later on, it can be quite a wide area that opens you up to a vulnerability. So it's important, if you're going to use a wireless network, to have encryption in place. Like I said, it works for wired as well, but it's essential on wireless networks. So if you've got a wireless network, you've got three, well, possibly even four choices really. There's three methods of encryption to choose from. The first one, which is a wired equivalent privacy, or WEP, is a really old system of encryption. And it's been broken so many times, it's almost absolutely useless. And what I'm going to do now actually is let's go back onto the Sky Hub, and I'm going to show you that on your security options on your router in home, you've got the options of selecting which version you want. So we've got disable. That means have absolutely no encryption whatsoever. Really not recommended to do that. And then we've got WEP, the wired equivalent privacy. Now we have this because some of the devices that might need to connect to your network might be a bit old, your printer perhaps, or maybe you're still running a machine with Windows XP. And I know a lot of big institutions such as hospitals, they still have very, very old machinery which don't have the modern equivalents for network security. So they still work on the old versions, which is insecure. So it's included just in case you have some sort of old machinery on there. And actually, although it's not very good and can easily be broken, it's certainly a lot better than not having one at all. So the other one is Wi-Fi protected access, WPA, and that has been sort of superseded now by WPA2. And WPA2 is, or was, believed to be absolutely unbreakable. So WPA2 is an improved version of WPA. Now we've got things here, some key terms that you don't need to be familiar with, but you might be if you see them in your router. So for example, here I've got WPA2 with a pre-shared key, PSK, and this algorithm, AES, for encrypting the data. So there's lots of sort of bits and pieces that sort of attach themselves, some acronyms that attach themselves to the actual security side. And one of them is WPA, which only supports this temporal key integrity protocol. It's a bit of an old protocol and it can be broken. While WPA2 supports this algorithm AES, and you've just seen that in action on my own hub. So WPA2 is capable of using the old version, the same as WPA, but it's also got a more advanced algorithm, the AES, which makes it really, really strong in the fact that it can't be hacked, or theoretically is not hackable. And for the last 14 years, it hasn't been. But as of 2017, it was. They managed to hack it. And later on, I'm going to show you two videos which really cover how to hack WPA2. WPA2 doesn't requires more, processing power than WPA, because the program to encode and decode the algorithm it uses is a little bit stronger, longer, more processing power is involved in encoding it. So here are the two videos. This is the work that I want you to do for today's lesson. The video on the left, which is only 10 minutes, just about 11 minutes long, is the one that I want you to watch. The work that I want you to do is, now that we're learning computer terms, you are beginning to probably not understand, but hear the computer science terms being used by people like these doctors or university lecturers talking to one another and they fluently use these terms, and you should begin or be beginning to get an understanding, at least recognize the terms even if you don't understand them. So the work from today's lesson is to watch the left hand side video, which I give you the link to. It'll be, I think, the first one, and I want you to write down 10 computing terms that they mention that you have learned during this series, this network series. The video on the right is a little bit longer, it's nearly 50 minutes long, but this is the person who actually broke the encryption. And he's talking about how he did it and what was necessary. It's a bit of a lengthy video. I don't need you to watch it. I've included it because A, he's the person who did it, so he's the hacker involved. So it might give you a bit of a sense of what you need to do if you want to hack. But towards the end of the video, he's kind of mentioning branches like the CIA in America and the NSA and WikiLeaks. This is an international thing. It's high security. And he does discuss one or two of the methods that they use to actually sort of break networks. So I think that would be nice to show you for one reason, and that is this course really is about programming and with a subculture of cybersecurity. So really, if you move on from this course to an A level, if this is what you want to do for computer science, you are going to meet cybersecurity. Now, just across the river, 20 odd miles away, we have a place called GCHQ, British Intelligence. I've got several former pupils working there, and I do know that when you are doing an A level, GCHQ bombard the teachers and yourselves with emails saying, come and work for us, come and work for us. So they're always looking for people to work on the security side of networks. And as I've said, in the past, I've had one or two pupils who work there. I don't know what they do. Obviously, they're sworn to secrecy and can't tell me. But it might be for you. It might be the route that you wish to take. And this would be a nice introduction to see how things are hacked, the language used, and what's needed. So if you're interested in a future in cybersecurity or working for GCHQ, I think that the right-hand video is a must-watch. If you're not, only interested in computer science maybe, or probably not even bothering to do computing once you leave year 11, then don't bother. You don't need to watch it. Really, all it's doing is putting the meat on the bones to the video that's on the left-hand side. They introduce it. The one on the right explains it all. The choice is yours. But don't forget the work, and I'll put a document in there explaining it, is that I want 10 terms or words that the video on the left uses that you have learned through this networking section. Okay, so that's it for this lesson. Pretty short from me, but obviously if you're going to watch the videos, this one's almost an hour long. Between them, they're an hour long. So that's plenty of work for you to do.